and bodies who would like to partner with us on this research to join us. And I would extend this invitation to each one of you who's present and who's passionate about building a carbon neutral India to join us in this mission. With these few words, I would hand you over to the most knowledgeable and the most powerful person in this entire industry. That is Mr. V. Suresh, who leads the initiative of IGBC. So let's have his vision on what carbon neutrality, means to CII and IGBC. Over to you, Suresh, sir.
Thank you, KD Singh sir. Thank you very much, and all the distinguished participants and our guest, Mr. Liu Leong, coming all the Chicago. It must be just early morning, very, very early morning over there in Chicago there. But it's a great pleasure to greet everybody. And for the great initiatives that ISRO has taken on this very important topic of ISRO's mission on building carbon neutral India. Let me congratulate KD. Under your leadership, this great initiative is taken. And CII IGBC has also a vision on carbon neutrality pretty close to what you are also planning to do. The vision of CII IGBC is to facilitate India to become one of the foremost countries in transforming net zero by 2050, embracing net zero as a win-win for the country and the organization pursuing the path. IGBC's initiative Net Zero is supported by the World Green Building Council, where IGBC represents India on the World Green Building Council. We aim to create a national movement of net zero, which we launched on the World Earth Day on the 22nd of April of this month, to influence the government policies on net zero and providing capacity building and knowledge sharing and promote technologies, very important, that will result in quantum jump in carbon reduction. Of course, it's a very major collaborative job. We got to work with the central government, state governments, developers, architects, consultants, manufacturers, bilateral, multilateral agencies, and technology providers in a very large way. To accelerate the adoption of the net zero concept in the country, IGBC, the organization which is over 21 years in the green building movement in the country, with roughly about 7.85 billion square feet of green footprint and wanting to do about 10 billion square feet by 2022, has already launched among this 29 rating system already on net zero energy, very popular under the chairmanship of Ashish Rakeja. I'm very happy he's also here now. He was the chairman for the particular rating system, and also net zero water, equally getting popular. And the work on net zero waste management is already afoot, and we will be able to get that by next, in about 3 weeks from now, the net zero waste also will be out. And therefore, culminating all this is a net zero carbon, and the work on this is already on. And hopefully by August 10, the net zero carbon rating of the IGBC also will be there. So you have the net zero energy, water, waste, and carbon put together as a total combination, because net zero carbon is the final conclusion element of the impact that it can produce. Our own approach in IGBC, the Indian Green Building Council, is to bring a paradigm shift by encouraging projects to perform the greenhouse gas inventory of embodied carbon, operational carbon, and end of the life carbon. Very important, 3 distinct areas, and we have to work on it. Encourage abatement strategies for maximizing energy efficiency and deployment of renewable. Very important. And we are in renewable energy. If we are about 84 gigawatt now, likely to go about 170 gigawatt by next year. And by 2025, will be 400 gigawatt of renewable energy. One of the biggest initiatives that will be coming in this sector. A lot of new components will come, as KD said, not only solar, but other components also. And adopting low carbon tech and material, and maximizing energy efficiency and deployment of renewables, which I just now said is very, very important. Switching to cleaner fuels and electric mobility is a very major component. And we have separate rating system available for all the mobility related issue, be it on the airports or the rail or the metros and fast train, etc., including vehicles. And creating carbon sinks and adopting carbon capture storage system, very important. This is a very important area. Storage this is a very major component. How do you deal with that? So the building projects which are adopted net zero energy concepts are already addressing operational carbon, and also a step away to become net zero carbon in the near future. Net zero carbon or carbon neutral development is a long drawn process, and many organizations and countries have committed to become net zero carbon by 2050. India itself is a signatory for that particular work. in continuation of the September 2015 joining 193 countries for Sustainable Development Goal by the year 2030. So there are a lot of challenges to become net zero carbon. Many opportunities exist, and both the businesses, industry, and the governments have to demonstrate leadership of a very large nature for net zero initiatives by showcasing benefits to the people and the planet. IGBC on its own, through its own rating system and green education and other related activities on projects being done in all across the country of a very large nature of impact. As I said, a 10 billion square feet of green footprint will be something like a top position in the country, in the world itself. And we hope we'll be able to push this agenda in a very big way. Not an easy job, got a real next 20 years time period from 2021 to 2030 and 2030 to 40 and 40 to 50 are important area of the 3 decades of work. We got a multi-stage-wise approach for every 5 years to have a course correction to do with the net zero carbon on the scaling the new benchmarks, on scaling new heights in that direction. Thank you very much.
Thank you, Suresh sir. I think it's a wonderful vision that IGBC and CII and you personally share. It's a great thing to have champions like you who are leading this all the way through. So thank you very much for your guiding words and for all the youngsters and everybody that is here to take this initiative of building a carbon neutral India forward. I would now like to invite Pankaj Dharkar sir, I think one of the champions of the industry once again, who's been championing the cause of energy efficiency, carbon neutrality. So I would request him to come in. I think Pankaj Dharkar sir needs no introduction. He's one of, I think, the leading and consultants not only in India but all over the world. So I think I would invite him to say a few words on what his vision is and what his vision of ASSOCHAM is about building a carbon neutral India. So welcome to you, Pankaj Dharkar sir.
Thank you very much. So first of all, good morning to Luke. I think thanks DCI for ensuring that your initial programs, you are getting stalwarts from the world. I've been fortunate to work with Luke in TC 9.12 ASHRAE committee for tall buildings, and people should know that Luke has designed the tallest building of the world, which is Burj Khalifa. So I've been fortunate to interact with him on other projects also, but he's a wonderful person, and I'm sure you have got the best person in the world to start this initiative on carbon neutrality. And I must congratulate the entire team member of ISHRAE, Delhi chapter, for putting this theme forward. I think something which nation needs, and a subject which is of great interest to all of us in ISHRAE. And I think you are going to lead nation as you have always done that from Delhi chapter. So Suhas, and great initiative. My really compliments to you, both of you, for taking this forward. Many people ask me why you started GEM from ASSOCHAM, and to them, I must admit that GEM is an infant stage as compared to IGBC, USGBC, and GREHA, but we are only ensuring that we are complementing good work being done by all these societies. And our strength comes from 450,000 members across the country, and our whole initiative is to create this awareness on green and sustainability, and now going towards carbon neutrality to the nation. And this is what we could complement the excellent work which is being done by IGBC, GREHA, and USGBC in India. We do believe that this movement which we have taken forward will only strengthen the country's sustainability objectives. Friends, we all know that going towards carbon neutrality is a long path. We have started getting customer inquiries, and I'm sure, and I'm really happy that this program is also being attended by my dear friend Ashish, who has been doing wonderful work on this subject again. I'm sure somewhere he would have guided you to choose this as a DCI theme. But friends, I think going forward on carbon neutrality is a long drawn process, going beyond net zero building, not only on technologies, but also on the passive side of it, selecting the materials which have low carbon content. So it's going to be an interesting topic for next 2 decades for all of us. And we all know that uh, this will definitely mean that we need to create more awareness on passive architecture, selecting right materials, emphasizing on and utilizing imperishable energy sources, emphasizing on corporate social responsibilities, also complementing UN SDG 30 goals. I think that is another route which is going to help all of us in creating that awareness, and also creating a huge awareness. That is what IGBC, Graha, USGBC, and of course GEM would be doing in terms of a huge challenge which country has. And of course, carbon footprint assessment report and carbon neutral certification is now catching up, as uh, we are also in the process of coming out with this new certification program very soon. The teams are working on this, and I think I will be moving forward as per our MOU. We'll be working with the Delhi chapter of ISHRE and also ASHRE India chapter towards creating these standards. Our just to update, the GEM certification program is completely based on ECBC 2017 and National Building Code of 2016. Mr. Suresh had been part of this, and we do believe that these 2 beautiful chapters are 2 beautiful standards which ECBC and NBC has given not only to the country but also to the globe. We are complementing also the SDG 2030 goals of UNEP. ASSOCHAM GEM certification has slowly started getting good recognition from various departments, governments, including CRESILs. Today I was very happy to be part of an inaugural session where the first railway station, which has a 5-star hotel, is being certified by 5 GEM certification. We have been working with several associations across the country on specifically for net zero. We have an agreement with TRRE, which is headed by none other than Dr. Rajendra Shende, who happens to be the former director of UNEP. So we just signed up our understanding with them, and he's helping us in creating these standards. Just to update you, during this pandemic, our association has been working very strongly with creating more than 100 plus seminars with 1 lakh plus registrations. 80,000 plus people attended this. We created 9 new chapters, created 14 MOUs, and very important, we created 80 MOUs with various universities across the country to create awareness about sustainability, and certified more than 2,000 professionals in the country during this 15 months time. So a fantastic job being done by entire team. And we do believe that going forward to carbon neutrality is going to really help us create more awareness on waste treatment, water treatment, energy car, and this is what is going to take to this path. So friends, come, let us take a pledge and create a green and environmentally friendly country, and complement our Prime Minister's goal of creating a sustainable country. Thank you so much, and thank you for making me part of this program. Thank you so much.
So thank you, Pankaj Tharkar, sir. So without taking much time, I'll hand it over to Suhas Mathur. Thank you for your enlightening words, and thank you very much for briefing all our audience and telling us the importance about carbon neutrality and the goal of sustainability. So I'll hand this over to Suhas Mathur to introduce our speaker for the day, and let's all hear him out, and then I think enjoy his presentation. So over to you, Suhas.
Yes, thank you everyone for your wonderful opening remarks. I would like now to introduce our speaker, Mr. Luke Leung, and he's an ASHRE fellow and a LEED fellow, and he has an incredible body of work. And at present, he is a director of sustainability engineering at Sustainable Engineering Studio for Skidmore, Owings and Merrill LLP, and he is, like I said, also a LEED fellow, ASHRE fellow, a member of the ASHRE COVID-19 Epidemic Task Force, the upcoming chair for Environmental Health Committee at ASHRAE, and his body of work, it includes master planning of Xiong'an, Burj Khalifa, Pertamina Tower, which is a net zero super tall building, and it used geothermal deep heat. He's also worked on the Beijing Finance Street, Embassy of Ottawa in Canada, Embassy in Beijing, and overall he has millions of square feet of low carbon development attributed to his body of work. So today's session is on whole building carbon, which includes both operational and embodied carbon. And I would like to pass it on to him to learn from his 20 years of experience and his vision for the future of carbon accounting in buildings. So over to you, Mr. Leung. Thank you.
Can you hear me okay? And is the PowerPoint showing up okay?
It's not showing up right now.
It's not showing up.
You'll have to share your screen once again.
Oh, okay.
Yes. I think when we play the national anthem, your screen got stopped sharing. So
okay.
Just share it one more time, please.
Yep.
Yes, it's visible now in the.
We can put the full screen, leaving out the left.
Yeah. Yes,
Yeah.
perfect.
Perfect.
Is it in the presentation mode?
Yes, yes.
Hold on 1 second.
And any attendees that want to ask a question, they can put in the question and answer chat box. I mean, the question and answer tab, which is next to the chat box at the bottom of the screen. Thank you.
Is it showing up okay now?
Yes,
Yes.
yes.
Is it showing up okay, right?
Yes, yes. Please
Okay.
go ahead.
Okay. So thank you for the Delhi chapter in India, ASHRAE, for the invitation. You know, when other people were talking earlier, I felt like we are just a choir singing the same song together, which is beautiful. It's a harmony. So I do want to let you know that the presentation I'm going to show you is not officially ASHRAE stand yet. It is in our work group, what we are seeing. So don't take it as the official ASHRAE stand, right? But it is in progress. Now, ASHRAE has set up the task force for building decarbonization. Just like what you guys were talking about, we see that it's important to get to a net zero world in the future. Inside this task force on building decarbonization, there are different work groups. I am heading the last one. It's the Embodied Carbon, LCA, otherwise the Whole Life Carbon Work Group. So I do want to talk to you about 3 things today. First, we're going to touch on just paint the background of the climate change and what is happening in US, not just in ASHRAE, but the architecture and building community in general about what they're seeing about the climate change. And then we talk about LCA, the methodology. Finally, I want to bring some case study and benchmarking numbers around the world. So we start think about and frame this whole life carbon and embodied carbon idea. So the first topic, climate change. Many of you know that by the year 2018, we are roughly about 1 degree C warmer than pre-industrial revolution days. And if nothing happened, 2050, 2100. Most people think that we have an opportunity here to get to 1.5 degrees C by 2050, so we can avoid much larger issues in the future. Now, of course, this is signed by the Paris Treaty in 2015. Most of the leaders were there. including at that time, the President of United States, Obama. And as some of you know that subsequently, US was one of the countries that withdrawn from the treaty, but now we are back in with the new administration. Now, not the whole world signed into the agreement. For example, Greenland didn't sign it. So the idea is, in order to get to 1.5 degrees C net zero by 2050, we need to do 45% reduction by 2030, and then a net zero economy by 2050. Now, at least if that's the case, we are looking at the area under the curve, given it is about 40 gigaton today. So the area under curve is about 540 gigatons. There's a 50% chance that that will be successful. Really just rolling the dice, half and half chance that we'll get to 1.5 degrees C. So 2030 challenge suggests we should try to do this. We should try to get to 65% reduction by 2030 and a net zero future by 2040, which accelerate 10 years ahead. And if we do that, the carbon budget is only 340 gigaton. And then we have a 67% chance of success. Now, in US, the AIA and many of the organizations is believing that may be the way we should go about it, trying to get to net zero by 2040. At least we try to aim at that target. In the Carbon Leadership Forum, which I'm part of, we're going to start a MEP 2040 commitment, meaning that we'll issue a commitment for the MEP firms around the world to commit to a MEP 2040 net zero economy future on whole life carbon. So I'm giving you a little preview of something that not public yet, but it will be coming. Nevertheless, this 2050 goal is agreed by many of the institution authorities out there. For example, New York City, they want a future of 70% renewable 2030, or 100% renewable by 2040. Many of you know that New York City has a local law 97. If you didn't perform to the carbon requirements, there are penalties. Now, some of the SOM building, I can tell you the penalty is really huge. It's in the range of $1 to $2 million US if you couldn't perform to that standard annually. So that's a big, big penalty will come. So there are other building codes in US trying to follow that, is establish these carbon targets. And then in California, in San Francisco, they have the net zero in 2019. Commercial building by 2022, 500,000 square feet, you have to be net zero. 2024, 250,000 square feet, 2030, 50,000 square feet. And of course, there are many cities in California start thinking about banning natural gas and fossil fuel. San Francisco banned natural gas 2020. And what you are looking at the screen right now on the left, you can see different municipalities in California is thinking about not allowing natural gas either in new building or a more holistic way. And you can also see some are approved, some are doing second reading, but this is happening. The idea that we're going to have to ban natural gas. And of course, in UK, in January 27, 2019, UK has committed to net zero by law. So this is happening in our cities, in our municipalities, in our countries, all across the world. Not only that, it's also happening in our companies. Microsoft, carbon negative by 2030. Now, in this here, you will see 75% of the Fortune 500 company is in this network. And many of the big names have already established sustainability goal. Some of them have net zero target. So this is not just happening in the government, but the commercial institutions, the financial companies, they are also looking at that. This is both as land lease. They want to be 100% renewable electricity by 2030, and then a net zero economy by 2040. So like we are doing a building with them right now in one of the cities, and one of the requirements is to study whole life carbon with that building. So this is happening around the world, even in our commercial development. So just now I painted you the picture of what the world is going, where the companies are going. Now let's look at the methodology of whole life carbon. Why do we need to look at this methodology? As you know already, building and infrastructure account for almost 39% of all the global carbon emissions, of which 11% is building material and construction. That's kind of the embodied carbon, right? So 11% out of 39% is quite a big number. And as the operation carbon getting to net zero, the embodied carbon piece will be larger. So from here to 2050, right? If we want 1.5 degrees C by 2050, in that 30 years, most people estimate about half of the emission will be from embodied carbon. So it's really need to focus on that. Now, the methodology that a lot of people have adopted, and ASHRAE is looking at it, and I'm gonna say it one more time. This is not yet the official stand of ASHRAE, but we are looking at different methodology. One of them is EN 15975, whole life carbon, of looking at how do we get to whole life carbon zero using this methodology. So when you look at this methodology, our operating energy is only a small piece of that. It's only B6, right? B7 is operational water. And I was so inspired just now when your team mentioned we're going to focus on net zero energy, net zero water, net zero waste, and net zero carbon. Now, even if we get to the operation zero on water and energy, that's just B6 and B7, right? So we still have this entire chart to think about. And B6 is operational energy. This is kind of the definition of what that B6 is. There are codes in this methodology that we start think about to making it operational net zero. So there are net zero operational code in US and also in China that enforce this net zero operational energy. That for a low-rise building is achievable in many projects. This is the first net zero school in New York City. The first thing you will notice is the amount of PV we have to put on the building, right? So by doing a whole series of reduction through passive measures and then put PV on the building, for example, we minimize the window wall ratio, and you can see the gigantic roof to shade the building and also provide PV, we can get to net zero. Daylighting to avoid natural light also give the occupants better learning environment. But there's an issue as you ratchet down the energy consumption, as you can see from the left to the right, right? When we reduce the energy consumption, oftentimes it's about the envelope. Your plug load doesn't really change. So as we ratchet down the operational energy, the plug load become a significant part of it because that is really difficult to reduce. And it becomes almost half of the energy consumption of this net zero school. you still have to offset that by PV, right? So it's not like it's really difficult to reduce plug load. So, but we know we can do that. Now, when we start looking at beyond the operational energy to the whole life carbon, the first piece is the embodied carbon. And out of the embodied carbon, the one we need to address immediately is the product stage carbon. Many of the HVAC equipment, they do not have EPDs. They do not have the product stage carbon information, but that's changing. I know some of you work with Trane. So Trane is one of the first manufacturer provide EPD, right? Their central actuator actually has EPD. And then we also got EPD from the other manufacturers. But that's one thing we need to address right away is to get the product stage carbon so that we can put it in our spec, right? So this is one of the sample, what you may see in the carbon, the natural carbon future. When you specify equipment, you might have to say the product stage A1 to A3, we want the water cooled chiller or air cooled chiller or VRF or heat pump to be certain amount of kilogram per carbon equivalent of product stage carbon in our spec. But the embodied carbon is bigger than that, right? This whole thing here you're seeing on the screen is the embodied carbon. It's the product stage, but then construction stage, how much carbon it needs to ship into your building and getting construct, and then the use stage and the end of life stage. So together, that's embodied carbon we need to address. Now, oftentimes this information, especially in the end of life stage, they may not be available, but that's changing. In the US, we are involved in a field research with National Renewable Energy Lab, particularly is to address the end of life stage of carbon. So we need those data. You know, we know a lot better now our buildings operational energy, but know a lot less about the embodied carbon of our building. So this is the embodied carbon definition. Now, one of the things to address is actually refrigerant. Refrigerant. Why is it important? Let me tell you this. Last year, okay, in all the federal building in US, think about how many buildings the US government own, right? Guess what percentage of the carbon emission is come from refrigerant leakage? Did you form a number in your head? 14%. Think about that number again. 14% of all the building owned by the federal government in US last year is from refrigerant leakage, right? So we know that's an important piece of information and also an important element to ratchet down if we want to get to net zero carbon. So in this development on the right we're doing in Sydney right now, the team is looking at a refrigerant with GWP, global warming potential of less than 10. So you're gonna have to veer away. Look at the global warming potential if you stay with R410A or R134A, right? If you look at a refrigerant of less than 10, your choice is very limited. And by the way, refrigerant, according to EN 15978, the leakage is not operation carbon under B6 is categorized as B1 in use carbon, okay? So be careful. Refrigerant, according to EN 15978, the leakage is not operational, it's part of P1. It's because when the building designed with the refrigerant, it embodied that refrigerant in there. When it starts leaking, you need to replace it. It's basically trying to replenish the embodied part of the building, right? Not using regular energy like B6. So there's a subtle difference in the methodology here in refrigerant. So the embodied carbon is key to use bio-based material is important. In this library here, we designed for Long Beach, which is built already. If we demo the building and build a new one, there's a 100-pound CO2 equivalent per square foot of structure in there. But if we reuse it, it can reduce it, reuse the garage at the bottom of the building. We can reduce that number to 35 pounds per CO2 equivalent per square feet, 65% reduction by reusing the existing garage. So, and then if we use concrete, it's about 70, and we change it to timber, it's about 35 pounds CO2 equivalent per square feet. So from the structure, we learn a couple of things. Number one is we have to move towards more bio-based material. Now there are stuff like bio-based polymer is coming, right? CO2 as a refrigerant, all those stuff are coming. So that's number one we need to learn is to, from the structural teams, is use more bio-based carbon neutral material. And number two, we need to learn from them is try to use existing stuff help in the whole life carbon. So whenever we can avoid diminishing things, demolition, the existing building, or if we can keep the existing ductwork, the whole life carbon can be reduced. So it's the embodied carbon, the operational carbon, and the circular economy, which is the D module you see on the right here. They compose of this whole life carbon, right? So this is what we need to address in the future, rather than just the operational carbon as we in the past has been focused on. And we need to kind of recycle, right? Recover and reuse, just like what we talk about and learn from the structural teams about using the bio-base and keep the existing material whenever we can. So that's the definition of whole life carbon. Now, this is quickly becoming law in US, as you can see from California to other states. They are already considering what they call the buy clean legislation. Basically, is they legislate and put codes in there to make you buy the elements that have lower embodied carbon, or in this case, the product stage carbon from A1 to A3. And there are plenty of developers around the world. Tishman Speyer is one of them, saying that we demand embodied carbon information from the manufacturer. And in US, GSA, the government buildings ownership, the entity that manage all the government building, soon they will come out with a program to say, we address embodied carbon. We want the EPD from the manufacturer to tell us how much embodied carbon the equipment has. So this is the development letter from Tishman requesting this information from manufacturer. So the developer asking for it. Now this is the Carbon Leadership Forum on SE 2050, AIA 2030. As I mentioned earlier, there will be a MEP 2040 come out. The professional organization also saying we are committed to a net zero future. This professional organization include the AIAs, the UK, the European agencies, and many Asian countries. And they committed to include the whole life carbon studies. And in this slide here, you see in UK, there are 95 signatures from the MEP companies. They committed to, in their future project, they will perform whole life carbon studies. And in US, what you're seeing on the screen right now, this company, in January this year, we actually author a letter together to the manufacturer saying, hey, look, the whole world want whole life carbon. Manufacturers, please provide us with your embodied carbon information on your HVAC equipment. So this is the letter we wrote to them. And in UK, they issue the embodied carbon of building services equipment, TM65, help the manufacturer to provide this information. And then they also has an Excel spreadsheet, what they call kind of the EPD simple or EPD light, to help the manufacturer provide their embodied carbon information. So this is happening all over the world. So there are tools and analysis that benchmarking will be required and targets will require to get to net zero. And those are the tools out there to help us. Now we are seeing the first round of benchmarking numbers on MEP. If you want to think about, well, what is the, kind of the EUI per square foot per year on the operational carbon, right? What is that embodied carbon per square meter? So there are some numbers coming up as you see on the screen here. This is MEP, and you can see it's below 100 kilogram per CO2 equivalent per square foot. That's the kind of the number we start seeing showing up. And of which of them, if you are high efficient, high performance system, it takes a little bit more embodied carbon compared to the standard equipment, but it's below 100 kilogram per CO2 equivalent per square meters. And anytime you have galvanized steel, it makes up a significant portion of that upfront or of that embodied carbon number, or rooftop package equipment, chiller, boilers, chill beams, right? Now, the other thing about this methodology is think about like an example here. Now, this is a 20,000 square foot building, right? So operation, we run the operation carbon on it, and we study 3 cases: 40% window wall ratio, 90% window wall ratio, double skin facade. Now, if you look at the embodied carbon of this 3 system, the double skin facade is no doubt going to take more embodied carbon, because there's basically 3 pane of window with a double skin and ventilated in there, right? So it just takes a lot more embodied carbon to make compared to the other systems. But guess what happened? If you start looking at the whole life cycle of the system, the facade, and the HVAC system, in this case is a VAV system. Now we look at the VAV system in this whole life cycle of 60 years. What you'll find out is, yeah, the facade is going to consume more embodied carbon, but it reduces the HVAC system size and the energy consumption. Not only that, the leakage of refrigerant throughout the life cycle of the building. So actually, if you look at this whole embodied carbon, now this is, by the way, this is embodied carbon and operating carbon. So the double skin actually is almost a wash with the full height glass on embodied carbon, but it would actually perform much better in the future for operating carbon. Similar for VRF system, it's actually slightly better for VRF in this case, because on the heating side of VRF is much more efficient. The COP is like, much more efficient than a boiler in a VAV. So the point here is, once you start looking at whole life carbon of the entire HVAC system and facade, you will come up with very different conclusion when you integrated the facade, HVAC system, and the refrigerant leakage. This is the energy analysis of VAV versus VRF, and VRF in this case is better because of the heating, really. And also the other thing is the part-time condition, because the VAV system and the part-time load is floor by floor unit. We still have to kick on the big fan, but the VRF, we can really just isolate the area. We need the VRF to kick it on. So the part load condition is, we can operate the system in a smaller unit, and also the heating. That's why the VRF was ahead. So in this here, the refrigerant is the orange here, and the operational carbon is the blue, right? Now, we are getting EPD data from manufacturer now, from HVAC manufacturers to address this whole life carbon. And EPD data will be required in order to establish this embodied carbon data. Now, they also address not only carbon, but a whole series of other impacts to the environment. So guess what happened is the next step. The next step is beyond carbon. So when we design a building or HVAC system, not only we know the carbon impact, but the holistic environmental impact to the building's impact to the environment. So that may be the future. It's not only just carbon, but this holistic impact on the environment of a building. So we just finished the second portion of the presentation, which is about the methodology and some of the impact from the methodology. If you use EN 15978, remember the refrigerant is going to categorize a little bit different, and you can see the impact of refrigerant. And when you look at this whole life carbon, how's that impact you compare to just looking at the operational carbon? Finally, we want to quickly go through a few case studies. The first one is in California, it's a while back. The interesting thing about that is, depending on, this is a CIPSE article, by the way. Now, the first thing jump out at you on the screen right now is the colorful pieces. The colorful pieces are the MEP carbon, right? The MEP embodied carbon. But what is interesting is the yellow piece. Low impact is 6%, medium impact is 12%, high impact is 23%. What is that? That is PV required to get to net zero. Now, here's the point. If you look at the left here, on a high impact building, if you want to get net zero on site, the embodied energy of PV is making up of 23% of the embodied carbon. Huge number. The question is it really better to have PV on site to get to net zero, which may make up 23% of your embodied carbon, or to have a wind turbine off-site, or to have a solar thermal power plant off-site and serve you the renewable energy? You know what don't we have? We do not have enough information about the embodied carbon of off-site renewable versus on-site renewable. It's difficult for us to draw those conclusions. We need more data. So think about that. It can be up to 23% of your embodied energy if you try to do net zero on site with PV panel, right? So this whole life carbon consideration open up many other considerations we have to think about. This is the O'Hare Airport embodied carbon. What we find out is the refrigerant, which is the orange piece, make up of 7%. Okay, so the refrigerant is actually the important part of that embodied carbon discussion. MEP is 18%. And then, of course, you have high performing equipment. In this case, is O'Hare. We're actually able to leak less refrigerant and more efficient on the high performance equipment. And that's the percentage difference, the refrigerant impact. So in this building here, Chicago Public Library, the whole life carbon is about below 600 kilogram CO2 equivalent per meter square. MEP is less than 100. Finally, I want to show you this chart here. It's done by the European, actually in this case is the LATI, which is basically London, RIBA, and they come up with a grading system, which is kind of like the pick up the BEQ in X-ray, right, it categorizes the building, how good you are, depending on the embodied carbon you have, which the chart I highlight on the right. So if you blow it up, so here are the numbers, right? In the A category, I mean, you have A to G category. And as you can see, the range of the upfront carbon could be from 1,100 to 100, and the embodied carbon could be 1,625 to the A plus category of 150. So there are benchmarkings out there that we can start look at to address embodied carbon. Now, obviously, this is European, maybe even UK based. So different country may be slightly different, but we start seeing this sort of benchmarking numbers, and we are trying to come up with that in X-ray in US. So all this is trying to get to a net zero world, whether it's 2040 or 2050, we can talk more about that. But we're gonna have to use a whole life carbon tool to look at how do we get there to a net zero future. So with that, we briefly talk about today 3 components. We look at the world, how we're gonna get to net zero in the future in the first section. Second section, we look at the methodology, the idea of EN 15978, and what are the potential impact on refrigerant, and how we look at a building as holistically whole life carbon, not just HVAC, but architecture to HVAC. So you can see the kind of carbon modeling of the future will be a holistic model of this whole building, including all the disciplines. And then the third category, we start looking at the case study and some of the benchmarking numbers that coming up with our European friends that can help to inform the world what are this potential number could be of whole life carbon. Just like the EUI in the past on operational, we're gonna have to start this generating this whole life carbon number that we have to get familiar with. With that, thank you for the time, and I'll be opening up for questions.
So Suhas, back to you, please.
Yes. Can you hear me? Right. So thank you so much for the wonderful presentation. We have one question from Mr. Swan or Miss Swan. I don't know, but the question is, wouldn't the use of off-site renewables while reducing embodied carbon on a site effectively shift embodied carbon to somebody else's carbon balance sheet? And it is not a true reduction in embodied carbon, just a reallocation. So what's your opinion on that?
Yes, I think that is the type of discussion we are having right now. You have the same operational discussion, right? Because a lot of the companies are outsourcing the data center rather than put it inside their company. They outsource their data center to the other people. Now, currently, on the operational carbon, if you do that, potentially you can categorize that operational carbon of a cloud data center to somebody else. So if you use off-site renewable, there's a potential that you can do similar. But that I think that's a really insightful question. Those are the questions that we have to answer. What type of methodology and accounting method to account for the energy that are off-site renewable versus on-site renewable? But the biggest problem is if we step back and forget about all those and look at this as one holistic system, we do not even know what's the global optimization point. Is it better for the society to have on-site renewable solar or off-site renewable energy? Because we do not know the whole life carbon per kilowatt hour from on-site versus off-site renewable holistically in different renewable energy generation method.
Thank you for that response. Mr. Rakeja has a question. So please unmute yourself and ask it.
Thank you, Suhas. Luke, wonderful presentation. Just transported us in
I cannot hear you. Can you speak louder?
I said a wonderful presentation transported us in a different world altogether. So quick question from my side. You showed a case study where the MEP had a much smaller carbon footprint, and the rest of the structure had a much larger one. When you took that into account, did you take the carbon footprint of all the electromechanical equipment installed there while manufacturing, transportation? All of that was taken into account to arrive at that number?
Great question. So most of the time right now, the data we have is really, when we say embodied carbon, oftentimes it's really the product stage carbon, A1 to A3. So those are the number we use, but we did include refrigerant and its leakage. End of life carbon is much more difficult. So in most of the data you saw just now is A1 to A3, holistically across the board. But what we find out is MEP in general is maybe 10-20% of that number, unless you include PV. PV is really tricky. Once you include it, if you need PV to get to net zero, that number could be really big.
Thank you. I have one question about how granular and how robust are the data sets to measure this kind of an impact, or are these still largely theoretical for most locations globally?
So there are, by the way, this is a great question. I think this is an insightful, and I think you probably know the answer already to that question too. Yes, right now on the MEP side, there are data, but like from the SIPC in US to S-Ray, where we are, the amount of equipment data we have is, probably in the range of maybe a couple hundred products. So, and they are location specific, so they are not very granular, right? And it's really difficult. We have maybe an air handling unit actually, manufactured in Germany. So how relevant that is to US, probably not very, probably need some study about it. But having said that, in US, we are working with Argonne National Lab and National Renewable Energy Lab. These national labs, they are coming up with much more granular data, and oftentimes they have local data to inform the more accurate information. So, I mean, if you think about where we were on operational energy, maybe like 20 years ago, 30 years ago, when we first start looking at the operational energy, we might be kind of draw some parallel there. It's like there's still a lot of granularity we have to get into to know the specifics. And for example, refrigerant embodied energy, as in how much carbon to manufacture the refrigerant, those numbers are still really difficult to get. Even the leakage number of refrigerant, there's a S-Ray 228P. If some of you look at the review earlier, there's actually a chart in there for refrigerant leakage that you can start using. But again, it's not very granular yet. We still need a lot more information to get to the specific and the regional and the local information. That's a great and insightful question.
Good morning, Luke. This is Sandeep Kohli. First of all, I congratulate you for making an excellent presentation. I have 25 years of experience in HVAC field and currently working as regional head North for Daikin. And I'm also a part of extended committee of Delhi chapter of ISRE. So I congratulate our president, Mr. KD Singh, for organizing this wonderful presentation. And of course, the presence of Mr. Dharkar, Mr. Suresh, Mr. Ashish Rakeja, Mr. Siddiqui, and all others makes it even more wonderful. I just want to share with you that Daikin as a company is also having one of the vision of carbon neutrality. That is also one of the parts of our Fusion 25, and that is a topic very close to our chairman, Mr. Inove, close to his heart. And in fact, we are in discussion with Mr. KD Singh, our president, that how we can collaborate and how we can support this initiative for DCI. And we are surely committed towards it. And we would need your expert views also to do the right things. Thanks once again. Wonderful presentation.
And by the way, we are familiar with your work, your company's work, and we also know that there are EPD. I shouldn't say EPD. There are embodied carbon data from your company. We actually seen the hard copy of those numbers. So yes, thank you for those numbers.
Very welcome.
Luke, there is one more question, which is that wouldn't the process, this whole process, benefit from the development of a uniform carbon pricing regime? The embedded LCA shows in most cases that a reused building has a lower value than a new building, given comparable building size and end uses. I'm not sure if that analysis holds true in all cases, but this is suggested by Mr. Swan. And also that in case of MEP equipment, given the issue of supply chains, carbon accounting becomes difficult in that case. So how deep can one go into the supply chain there?
Wow, there's many layers to that question, at least 3 layers of that. Maybe I'll answer the third one first. The supply chain number is difficult. That's why it's, oftentimes we look at A1 to A3, which is really just cradle to the gate of the factory, and try to understand that, because we understand from our manufacturers that that's a number that maybe they are able to get better. That's number one. Number two, regarding the existing and the new, that really need a whole life carbon study to understand that. I mean, today we do energy modeling. Tomorrow, you can just imagine somebody will perform this kind of energy plus, I call it, right? So it's not just energy plus, which is operational, it's energy plus, which is plus water, and then plus all the embodied and whole life carbon. And so it's really through that process we'll know better. To your first question about the price of carbon, we've been looking at that carefully. And as you can imagine, there's a really wide range of carbon, from the carbon trading in China to some of the carbon price in US. They could be ranged anywhere from, a few dollars to $10 to over $90. But in US, we start thinking about the social cost of carbon. And there's a number floating out there about $50 per $50 per ton of the social cost of carbon. But we are still struggling to try to get to a number that everybody will be agreed. In the best of all world, it will be like a stock market. You can buy and sell, and it's in that market structure you can come up with a price, which China try to do it by trading it, but it's still, because there's not enough people interested in trading, so the number is artificial a little bit. But yes, we're trying to converge into a number, but it's still in the process. But definitely there's some suggestion about social cost of 50 tons of carbon. And and also, how do you discount carbon from the future back into now, right? So some organizations suggest, because there's a dollar associated with the carbon, so potentially you can use the inflation, just like how we discount money today, to discount the carbon back into now. But whether that is the right methodology, we don't know yet, because obviously it may not be identical as inflation when you think about today's carbon versus future's carbon.
Right. Thank you for that perspective. We'll just have one last comment from Mr. Dharkar. He has his hand raised, and then I'll pass it on to Mr. Rakheja for the concluding remarks.
Thank you, Luke, for that wonderful presentation. I saw a couple of case studies which you shown, and I found that embodied energy of envelope could be more important. I think on MEP, you are in advanced stage of computing with help of several companies in US. So I think, and in your country, probably glass is one major material which is being used currently.
We lost you.
Yeah. Mr. Dharkar, your voice is not audible.
Yeah, we lost you, Pankaj sir.
I'm not sure I can hear you. I'm cutting in and out. I don't.
Yeah. I think there is a connection problem at his end.
I was wondering how
Yes.
are you working from ASHRAE on other with other societies for embodied energy of other materials. So is my voice clear, Suhas? Or?
Now it is clear. I think we lost you in between. Were you referring to the glass, embodied carbon of glass? Or what
I
was it?
was
Could you repeat?
trying to understand how are we working in ASHRAE with other organizations to understand the embodied carbon content of other envelope material other than glass. Glass, I am very clear. I just want to understand how should we proceed in our country to work with other labs, other societies, other working groups. So just wanted your guidance on that, Luke.
Yeah, well, there are a couple of things. Number one, I should also talk to you about this. So in our work group, we are looking for a couple people from actually India to join us to work together on this topic. So I don't know how that methodology can work. Maybe we can talk more later. So that is one thing, because in our work group, we compose of people from SIPSI, we compose of people from the Middle East. We are looking for people from China and Hong Kong, and definitely from India. We believe if India and China are not on, and I'm so glad we're singing this song together as a choir, because unless China and India are on board, the world is not going to get to net zero by 2050. So I guess I'm advertising my work group with your team to look for a couple of people that are willing to work with us on that. On the second part of that is, I don't know how your country works, but in our country, the labs, the US national labs, are the people that are supported by Department of Energy, and they have resources and funding to dive into this topic, because the US federal government right now committed to 2050 net zero economy. So they are funding DOE to do all this research. And that's how we get to look at some of this data in much better granularity than what we were able to do in the past. Now, there is a database out there, it's called GREET, G-R-E-E-T. It's done by Argonne National Lab. It's been around for almost 20 years. Maybe I'm exaggerating, maybe 10 plus years. So that database used to be for automobiles, but they have all the number for in very good granularity. So they are expanding that into building industry. So you can go to that database and look for stuff. And by the way, I can share with you with what we have. Some of you are familiar with the SIPSI's EPD database, the Excel spreadsheet to calculate embodied carbon. If they are interested in this group, we are happy to share those information with you, or you can share your information with us. The point is, look, nobody can do this by one group or one entity. It's going to be all the people work together, just like what we do here, singing the same song as a choir. That will make the most beautiful music.
Thank you, Luke. Thank you for that.
Yes, Mr. Suresh, please.
Luke, that was a fantastic presentation. Let me compliment you, like others have done. It opened up large number of options there. It only shows the amount of work that requires to be done, both in respect of the embodied energy, not only for the building material, but also for the MEP. And that's a very interesting component. We never, for us, the embodied energy component is always of the building materials, the walling material, glass, aluminum, roofing material, various other building materials that go into it. But on the MEP system itself, the embodied energy component can come over there. Is a very interesting revelation that we could get that. And I like the analysis of the combination of the embodied energy coming on that. With respect to your specific offer on the data, because we'll be most happy to get that. And IGBC as an organization would like to very much work very closely with your group there. Fortunately, with Ashish Rekeja already there representing our group on the ASHRAE board, I'm sure his interaction with you will be very helpful for us to shape up. And let me be very frank and candid. We are all on a learning curve. And on this particular issue, on the whole issue of going the net zero, the whole country is really waking up to the whole thing of the commitments all come at the highest level of the 2030 commitment, 2050 commitment at various locations there. But what does it mean in terms of operating in the built environment is the biggest challenge. And that's where the type of good head start that organizations like ASHRAE has done. And I'm very happy that you mentioned about two important components that come from the American Institute of Architects, and they had the Vision 2030 recently they brought out. AIA was a very good one. But I was very happy, and I always think that architects could do the material, but the structural component is most important, where the column and beam and walls for all the forces of the building, tall buildings that come over there, how will you bring down the embodied energy for the steel? And because you said a lot of biomaterials are required, bio-based materials are required, and you said bio-based polymer. That's it. Polymer is easy, but it does a real structural one for that's serious business. How do you really bring that down? Would it mean that we are going to get a major reduction from all those super tall buildings of 80 stories, 100 stories? Will all come down to the low-rise, maybe around 10 to 20 story type of building, because then you don't require. Is it going to be a new scenario going to work out? Because all the examples that you showed are all low floor buildings of 2 floors or 3 floors buildings that you indicated. So the structural cost is, and they're given a thing, the structural engineers are given by 2050 only, they'll be able to achieve that to bring reduction there. Would you like to take up that?
Yes, that is a really, truly insightful and exciting question. I would like to just talk with you a little bit more, because we've been thinking a lot about that. There's a few things there. Number one, the structural embodied carbon per square meter is higher for tall buildings, no doubt.
Yes.
They are low buildings, tall buildings, very tall building, the per square meter carbon is higher in the embodied carbon. But having said that, I also want to let you know that when a tall building, the way it's shaped, right? The way the building shaped has huge impact to the embodied carbon, because it's going to be about wind once you go certain height, or maybe earthquake forces, but mostly it's about wind once you're tall. And let me give you an example. In one of the 540-meter tall building in Tianjin, China, by shaping the building to work with the wind, we actually reduce 40% of the total structure of the building by just changing the shape of the building. So that's one of the key, is to reduce the amount of structural material in there. Now, after we do that, you probably already heard of all the movement of, concrete cure and other ways to put the carbon back in there. Use of the more renewable mix than the traditional ones. And also on the steel side, they are actually thinking about using renewable energy, their furnace. So all those things are happening, but yeah, you're right. It's not as fast as we want, especially cement is still a big problem. But it's this kind of process of think about how do we reduce the most material, switching to a lot of the bio-based material, and then for whatever we cannot switch to, we're going to have to use renewable energy. And the last way to do it is offset. So that's what our structural team is thinking to get to SE 2050.
2050.
And that's
they're asking for more time to get there. Things right. Okay.
Yeah. No, that's on our mind, and we are thinking, how do we do that?
Singapore has been trying to work structural non-structural, finishes, and services. They are broken into four components I could recently see interacting with the team over there. They're covering for each one of those things on embodied energy. And of course, services, you already told MEP how it's coming separately. But they're covered structure, non-structural, finishes, and services. That's the way they're trying to get that. I think they're a little more, a very holistic approach they're trying to give, the Singapore Green Building Council.
Yeah. Yeah. That's interesting to know.
Yes, sir.
So
very interesting.
Right.
It will be part of my invitation to the team here is hopefully if you can help us to identify a couple people from your team that could join us in the embodied carbon and the LCAs.
And Luke, I want to just tell that we got the annual Green Building Congress. It's the most important event where we have large participation of the order of 5,000 people participating, even on a virtual platform. So that's going to be November 2nd week. We would like to invite you, and interesting, this year's theme for the Green Building Congress is on the net zero. And because we know that if many things have got to come happening on that, unless we provide that in our annual Green Building Congress for setting the whole agenda in terms of all the other rating, nothing can work. So we would like to invite you to come and talk on that topic. It'll be very good. A good half an hour, 45-minute session to really bring out the whole strategy that you put forward, which was very interesting, very informative, and very educative. I'm sure all our participants are multi-stakeholder groups of architects, engineers, services people, MEP professionals, everybody is involved in that, manufacturers, everybody is there. We'll formally write to you. And I was very, very happy that I joined till the end of the program. That's what KD wanted me to be there for the whole program. And to hear you and the clarifications. Thank you very much.
Yeah, I'm happy to be there, to be part of the choir, to sing the same song together.
Yes, sure. We will formally invite you.
Right. Thank you. Thank you so much, gentlemen. I'd like to proceed with concluding remarks by Mr. Rakeja and followed by Dr. Priyanka's vote of thanks. Thank you.
Thank you, Suhas. Wonderful program. I think it was gripping, absolutely. And great.
So a little closer to the mic, Ashish.
Okay, sir, I'll do that.
Now better, now better.
Is it okay?
Yeah, no, perfect.
Okay, thank you. Great talk, Luke. Enjoyed this, and especially the interaction after that, which the members had. I just want to add about the journey that we are having in India with regards to moving towards the carbon neutrality. I think it's something that I'd love to share with you. Mr. Suresh spoke about the initiatives which have been taken by the Indian Green Building Council. I'll share that we do have now a couple of net zero energy buildings which are operational in the country. We started our journey nearly a decade.
Your voice is going down.
Okay. Let me do some magic here, sir.
Voice dropping.
Tell me if you can hear me now.
Better.
Is
or
this
maybe
okay?
Video cut out.
Perfect, sir. Please go ahead.
Okay. So I was saying that in India, we started a journey about a decade back. The small building of just about 10,000 square feet, which moved to net zero. Since then, there has been a big progress in terms of what we have done with the larger buildings. In fact, from a government setup to a private building, private owners, they've all started experimenting with it. And going on to an airport also. We have an airport in the southern part of the country, which is a net zero energy airport. So this journey has been going on, and it's been that's what prompted the Indian Green Building Council to come out with a rating system for the net zero energy buildings. And we have some similar rating systems available from US Green Building Council also, which are used in India. Now that's a journey which is well on the way, because India is blessed with a lot of with sunlight, especially because on that side we do have a challenge with the wind, but definitely on the sun we are blessed to have more than 300 days of sunlight around the year. I think the progress is well received in terms that even the developers, which is the speculative building being done, now asking for a net zero energy building to showcase that they are in position to offer something which is above what the rest of the developers are doing. So that's because from a private user going to a speculative development, I think that's a big change that happens. Now we also have the next part of the journey, which is net zero water buildings being done. India is a water-starved country, even though we get plenty of rainfall, but due to the poor water management which exists in most part of the world, we do have our challenges with the water. Now with the net zero water focus being there and IGBC coming out with the net zero water rating system, there are now townships, there are buildings, there are larger developments which are now looking at that. And the third part of this triology is moving on to the moving to the net zero waste, which also has commenced. And because with 1.3 billion people, we produce a lot of waste that needs to be also taken into account. So topics like waste to energy and it's something which is gaining, or circular economy does gain a lot of traction here. Interestingly, in terms of sustainability, the buildings in India have reached a very high level, I would say, because they are able to use good amount of daylighting. We see buildings which are 80-90% daylit. In fact, we push the envelopes there. In terms of the materials, in terms of the equipment efficiency, everything is being talked about in a big way. And you have a clear distinction where we are talking about the EPIs. Some of our representatives have also been at the ASHRAE conferences where they have shared this data in terms of how the energy use reduction in the buildings is being carried out. I think now is the time for us to move on to the carbon neutrality, and that's something what Mr. Suresh also said, that it's something that we have just embarked upon. It's something which we need to do a lot of work. We do not have we have challenges in terms of the carbon labeling of the equipment. It's something the carbon labels are not available on the material front where there's a maximum issues are, but that's something which is going forward. Now, ISHRAE as a society has also taken a big step in terms of coming out with a standard on energy performance of the buildings. If you look at 90.1, if you look at, we have similar energy code in India called ECBC. These are all the codes and the standards. They are looking at the building energy efficiency. They go down to the equipment efficiency in terms of what you should be doing. What should the COP of a chiller be? What should the percentage efficiency of the pump be? And they would maybe, like our energy code in India defines what we call an energy performance index, EPI. So many kilowatt hour per square meter per year is what we are saying should be of the building performance. But we have no guidance available in terms of when you want to drill down, what are the subsystems consuming? What are the HVAC system alone are consuming? We can say, oh, in America, there's a building which consumes 60%. Possibly in India also, they're consuming 60%. What about the plumbing? What about the building envelope? What is the contribution it has when our ambient temperatures are 45 degrees? Or in your side, something about 115 degrees F. So what is the performance happening? What is lighting contributing? So we've been now, ISHRAE has taken a project in which we are drilling down the building energy performance, finding out what the subsystems are consuming, and label the buildings with respect to that too. So there is a class A, class B, and a class C performance in which you can identify what should your HVAC systems consume. If you are a class A building, class A would be the best in class. Class B would be a normal building, and class C is sort of an entry-level building. So what should the performance of the subsystem be at that level? Now, this is the data which is going to be extremely useful for the building operators because they can benchmark their buildings, their subsystems performance to see where do they stand. We do have help coming in from Indian Green Building Council and many other participants there who are contributing their data. And that is what is the standard which ISHRAE is going to come out with early next year. And incidentally, at ASHRAE also, we have been talking about it with the 90.1 committee on the same thing. They have also been, we were having a sort of exchange on that there. So these are exciting times. I think to hear from you on the carbon neutrality, it was excellent. And that's something sort of opens the eyes. We will definitely, from ISRE, Chakedi Singh or somebody from IGBC would reach out to you to be part of the 4-member team that you said in terms of contributing from India. We do have data available. We do have experience available here, which we'd love to share and possibly carry back the learnings from there too. So thank you very much for doing that. Great talk and really enjoyed this. Thank you, KD, for organizing it. I think you're really taking your carbon neutral theme to a different level this year. Great. Thank you.
Thank you.
Let's work together to create a better world.
Nice orchestra. Nice orchestra, as you said. All symphony, all working together. Talmel. In Indian language, we use the talmel. That means we are synchronizing, all talking in the same, blending it together in the right way. No false notes anywhere. That's a big message. No false notes.
Harmony, yes.
Harmony is the right word.
Yeah, taking it forward, I would like to thank Mr. Liu Leong for being together with us and for such an invigorating session, which had our minds pumping for more knowledge, and sharing with you was all so informative for all of us. And the discussion that we had took it to another level altogether. So as you say that climate change is a reality, and the earlier we acknowledge it, the better it is. And I think with all of us moving forward in the good right direction together, I think that's what we talk about when we say it's in harmony, or in India, we say, yes, talmel. So I would like to thank you for giving us such a good session, such a mind-boggling session, I would say. And yes, there are certain points that I really liked in your session was about the life cycle assessment that you had talked about, which is the further way when we talk about circular economy, because now there is a lot of hue and cry. Now people are acknowledging circular economy is the way of life. So moving from that to bio-based material to be used in the built environment, I think we had a whole package for us today. And on behalf of Delhi chapter of ISRE, I would like to thank you for sparing your precious time today and being with us. And we look forward to this collaboration further. Thank you. Thanks to all of you.
Thank you.
Thank you everyone for joining us. And with the permission of our president, I would like to call this session to an end.
Yeah, so before we end this session, thank you everybody. Thank you, Mr. Liu Kling, Mr. V. Suresh, Ashish Akeja sir, Pankaj Dharkar, and each and every participant who's been here. I think we've all gone back much richer in knowledge, a lot of things to think about and take things forward and build a beautiful world for ourselves to live in and for the future generations to come. So thank you very much, Mr. Liu Kling, for this wonderful presentation. I think a heartfelt thanks from all of us, these Delhi chapter of ISRE, IGBC, CII, our other partners. Each one of us is, greatly, highly indebted to you for having spared your time today. So thank you very much. Thank you, Suhas, for, I think all credit goes to you. Many congratulations to you for having organized this. So thank you very much. And the entire DCI admin team was put in a huge effort to put this program together. So thank you, everybody. Thank you very much.
Yeah, great job, Suhas, and of course, Tapas and all ISRE team. Great job.
Thanks.
Really commendable.
Have a good day, Mr. Leung, and good evening to everybody who's joined. Thank you.
Bye-bye.
Bye-bye.
Thanks, Suhas. Thanks.
Bye. Bye,
Thank
Liu.
you very much, sir. Thank you, everybody. Thank you.
Everyone.